In this problem, we have two runners running around a track that is supposed to be 1 kilometer, or 1,000 meters. The first runner, runner 1, runs around the track with a time of 2 minutes and 27.95 seconds. So that's 60 seconds plus 60 seconds for the 2 minutes, plus 27.95 seconds, for a total time of 147.95 seconds. And runner 2 runs a time, t sub 2, of 2 minutes and 28.15 seconds. So 60 seconds plus 60 seconds plus 28.15 seconds, for a total time for runner 2 of 148.15 seconds. Now, the premise of this problem is this. If we just look at these times alone, then it looks like runner 1 is faster because runner 1 has a shorter time. But, for all we know, the length of track 2 could be slightly longer. We don't know for sure that the lengths of the track are the same. And we can imagine that if track 2 was much longer, then actually runner 2 would be faster, because they managed to run a longer distance in a shorter time. So the problem is asking, how big can that length discrepancy potentially be before we can no longer safely say that runner 1 is faster? So to tackle this problem, let's figure out what the length difference would have to be in the case where the two runners' speeds are equal. So where s sub 1 is equal to s sub 2. That'll be the point where we can no longer say that runner 1 is faster. And using our equation for speed, distance over time, this is the case where the length of track 1 divided by runner 1's time is equal to the length of track 2 divided by runner 2's time. So we just need to figure out what the length difference would be if this is true. So taking that equation in mind, we want to find the length difference, or L sub 2 minus L sub 1. So we've got L2 and L1, and since it's a 1 kilometer race, we can probably assume that one of them has a length of approximately 1,000 meters. But what's more important is finding the difference between them. So if we take the equality we just discussed a moment ago, we can algebraically rewrite this to solve for one of the two lengths. And so I'm going to do this with L2. So if we multiply both sides of the equation by T2, then algebraically we can find that L sub 2 is equal to T sub 2 divided by T sub 1, all multiplied by L sub 1. So let's plug that in for our equation for the distance. So L sub 2 minus L sub 1 is now equal to, instead of L sub 2, we're going to write T sub 2 L sub 1 divided by T sub 1 minus L sub 1. And to simplify this equation a bit, I'm going to factor the L sub 1's out of a parentheses. So this becomes L sub 1 multiplied by T sub 2 divided by T sub 1 minus 1. So now let's just plug in some values into this equation. Again, we're going to assume that L1 has a value of approximately 1,000 meters. And we're multiplying this by T sub 2 over T sub 1 minus 1. So T sub 2 is given in the problem as 148.15 seconds, and T sub 1 has a value of 147.95 seconds. Subtract 1, put all this into a calculator, and we find a length difference of approximately 1.4 meters. So what this tells us is that if the length of track 2 is longer than the length of track 1 by 1.4 meters or more, then we can no longer say that runner 1 is the faster runner, because in that case, it would actually be runner 2 that's faster. And that is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. And if you have a request or a question, leave a comment down below, and I'll do my best to help you out as best I can. That's all for now, and I hope you all have a lovely day. Bye-bye.